Hello everyone and welcome to tutorial number 3. Here we see how we can explore two input parameters manually. So this allows us for some automated parameter exploration. We will generate many merger trees and run many different models. To keep the output folders a bit in order, we can set a specific path output. So let's maybe do this at the beginning. So open scripts, wrapper, loop trees, and find where is path output. So here I already prepared a path for this, for the tutorial. And we also have to do the same with script wrapper, the analysis. And here we need to look for a folder name. And we save. And I will just start the script and then explain what is happening. So basically, all you have to do is to run this Python script, and with Python 3, script wrapper loop trees. So what will happen here is we want to change the parameters max and eta3. Eta3 is a population 3 star formation efficiency. And for each new combination of these parameters, we run 3 EPS merger trees. And we do this either until we have 32 combinations or for 30 minutes. So the Python script launches automatically many calculations in parallel. And here you see it waits between each run a little bit. And therefore, it can happen that the output looks a bit funny or fluctuating, because here in the terminal, we now override information from the Python script and from multiple A-SLOTH runs that run in parallel. But we see the first one already finished. And so now we can just wait. One note, this is now a bit consuming regarding RAM and CPUs. So if you can run this on a bit bigger computer, that would be good, but it should also work on just a normal laptop. So now let's wait for probably about 30 minutes until this script has finished. Okay, now the code has finished. And as you can see, the Python script already finished up here, but then Fortran continued to run, A-SLOTH continued to run, and then the last A-SLOTH finished here. And you might have the same problem that your prompter does not return to the terminal command line. You can just press enter and it should work. So this is really just because the Python script finishes before the Fortran runs. Anyway, now we ran almost 100 EPS merger trees in about half an hour. And we can check the folder, and then you also understand why we have set this output path before. So here we have now around 100 different folders and various parameter information. And now for each parameter, we have one random combination of max and star formation efficiency. And the 3 folders are 3 different random seeds to have some stochastic sampling between also the runs. And again, setting the output path and folder name is not mandatory, it's optional. If you don't do it, then you get all this information in your A-SLOTH folder. So let's go back to the A-SLOTH folder and continue analyzing the data. So we also provide a script for this, which is called analyze trees. So again, with Python 3, and analyze scripts and analyze trees. And so what this will do, it will also tell you, it will go through all these folders by, so here you see para 000, para 111. So it will go in triples and extract the important information, and we can just wait for this to finish. And the script has finished, and it should have produced this parameter exploration file. Let's just check. Yes. So this parameter exploration is the latest file that we obtained. And you can open this, you can explore it for yourself. It's like a big table with data, but we also provided a script to visualize this. So, and this will produce a grid plot that probably looks roughly like this. And exactly, it's like a quell of data, big file, and let's see, there it is. So let's also have a look at this. And what we're about to see is, so in the left column, we see the changes with the IMF max, and on the right column with eta 3. So we change both at the same time. So therefore, these are not like monotonic functions, but we can see some trends. And so let's maybe just go to the bottom. So again, here we see the trends. On the left side, the y-axis are all the different quantifications and comparison to observations. So you can check our A-SLOTH main paper to understand what is going on here, but you already see that there are some direct correlations, like for example, the tau with the star formation efficiency, or the stellar mass of the Milky Way with the star formation efficiency shows quite clear, almost monotonic correlations. And this was tutorial number 3. Thank you very much.